In the last video, we have discussed about what is bar bending schedule, what is the key component, and why it is important, and what is the step-by-step procedure for preparing a bar bending schedule. In today's video, I will discuss about how to calculate bar bending schedule or how to prepare bar bending schedule for a foundation. So stay tuned until the end to get the full information about the cutting length, about the bend length, and how to calculate bend whenever it is 90-degree, and how to prepare and how to make the full quantity of steel from the bar bending schedule. I will make it in-depth analysis for this. So stay tuned until the end to get the full information about the bar bending schedules of a foundation. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. For the foundation, what we need to know, that is first thing is understanding the structural drawings. We need to understand what is structural drawing and how to read structural drawing, and how to read and how to understand what is the bar diameter, what is the spacing, and how to place and details everything about the structural drawing. Then bar shape and the cutting length. What is the bar shape and what is the cutting length, that we need to prepare whenever we are preparing a foundation bar bending schedule. And then calculation of total weight, and then documentation. So these are the things we need to understand whenever we are preparing a bar bending schedule for a foundation. The first thing in the bar bending schedule, what we need to know, we need to understand the structural drawing. If we cannot read the structural drawing properly, we cannot make the prepare the bar bending schedule. So let's see how to prepare, how to read the structural drawing so that we can easily understand to or prepare bar bending schedule for a foundation. So this is a foundation of a building. See, here is a how many building foundation is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 foundation. Why I am calculating number of foundation? Because it will help me to get the total quantity of steel for the entire foundation of the building. Now, there are all the foundation are not the same. So what type of foundation is there? Here it is a F1, F2, F3, again it is F1, it is F4, and this is F5, this is F5. So there are 5 types of foundation. So we need to prepare 5 different bar bending schedule for the 5 types of foundation. But today's video, I will only show one example for the F1, and other you have to prepare as your homework. So this one, F1. So this foundation we have identified that the foundation marked is F1. Now what we need to check, what is the dimension of the foundation. What is the dimension? 6250 and 4 meter. Along north south is 6.2 meter, and along east west is 4 meter. Sorry, no, along northeast is north south is 4 meter, and east west is 6.2 meter. Now after that, we need to understand what is the depth of the foundation. Here it is, we cannot find out the depth because it is not mentioned, it is on the plan. Now we have to go for the section. It is the section. See, in this section, it is already shown T. Why it is T? Because it has 5 types of different foundation, and this is a typical drawing. And this T, where I will find, we will find it in the table where the all details is mentioned. See, foundation mark F1 is depth of footing T is 450. So now we are understand what is that our dimension 6.25 into 4 meter into 450 mm is our foundation size. Now we are get the foundation size. Now we need to understand what is the reinforcement is there. Here is the plan of foundation. Here we can see there are different types of reinforcement: A, B, C, and D. So there are 4 types of reinforcement available in this foundation. Now, how it is distributed in the 4 types of foundation, we need to know how it is placed in the section or in the foundation. Here we need to check the sectional view or the sectional drawing. Here it is show section in the section 1-1. Now, main bar is main reinforcement bar that is shown is A. What does it mean? This is the A bar because we are seeing from this side whenever we cutting section AA, and this bar will shown in the full length. So A is the bottom main reinforcement, and this direction bar we will see the dot. See all these dot, and this dot is denoted as B. So which means B is the bottom distribution bar. So A is the bottom main bar, B is the bottom distribution bar. Similarly, C is the top main bar, and D is the top distribution bar. Now, what is A, B, C, D? What is the diameter and what is the spacing? Again, it will find out from the table itself. See, A is 16 torr, 150 center. Here it is also. Luckily, we have all the same bar from both X and Y direction for the foundation F1. Now, we need to prepare bar bending schedule. Why? See, the length is 6.2 meter. Now we have the bar length of 12 meter. Now we cannot place the 12-meter bar because you only need the 6.2 meter. So what we will do, 6.2 meter will cut in the place in the foundation. These things will also not be happen. It will also give the erroneous result, and it will not be making the product conformity. Now check the shape of the bar. This is the straight portion and there is a L. So it is a form of U bar. So here is also a vertical portion. Now we need to calculate the vertical portion also, as well as from the horizontal or the straight portion also. First, we need to check the straight portion. Okay. So straight portion, how we'll check? This direction is 6.25 meter. So total length will be 6.25 meter. No, it will be wrong, because every foundation or every concrete has the clear cover. Why? Clear cover is ensuring the product conformity or the durability of the concrete. If the clear cover is not adequate, the moisture and the other harmful chemical will enter into the concrete, and it will corrode the reinforcement, which will eventually make the concrete more durable, and it will break. So we need to provide the clear cover, and in this clear cover zone we should not place any reinforcement. So whenever we are calculating the total length, we need to minus this clear cover, or we have to deduct this clear cover from the both end. So what is the clear cover, and how much of the clear cover, how we will know? See, in the notes there will always mention the cover. Here it is, see, the clear cover to for main distribution shall be as footing 50 mm, 50 mm, 50 mm. So what is the cover? Here it's in this phase also 50 mm and this phase also 50 mm. Now we know this dimension is 6.25 meter. For 6.25 meter, from both sides 50-50 will be the less, so it will be 6.15 meter. Now let's jump into the BBS format, and in the BBS format I will show how to calculate. And so in a single format we will find out the diameter, we will find out the spacing, we will find out the shape, and we will find out the total quantity or total tonnage of the reinforcement. So let's jump into the bar bending schedule format. See, this is the standard format of the bar bending schedule. It is also in the IS code also here we mention. So what is this we need to prepare whenever we are preparing a bar bending schedule? First things, we need to mention the project name. What is the project name? And then who is the client, and then who is the consultant or the third party, and then execution agency or construction agency or the main contractor. Then name of the work, reinforcement detail or the bar bending schedule for foundation from XYZ building, and then refer drawing number, which drawing we are referring. That also we need to mention. That in this refer drawing we need to mention two drawing. One is the structural drawing, where is the preliminary things is mentioned, what is that bar diameter and the spacing, and another thing is the shop drawings. Or in the shop drawing it will be in detail positioning, detail splicing, detail shape and everything. So that drawing also, reference drawing also mentioned here. Now the first thing is here name, and then bar mark. See, I am mentioning is F1, we have taken 6.25 into 4000 into 450 is a day. Now the bottom main bar, that is B1, we have already shown in the drawing, and the spacing is 150 centimeters. Now diameter bar of 16, and number of bar, see in this direction you say in the 150 center will be bar, but how much number of bar we need to provide. Now how we'll calculate? So total length, we see that it is a 400 meters, because in the total length of the bar is 6.25, and in the 4 meter direction, it will place in 150 center distance. So to 4 meter divided by 150. No, again, we need to deduct the clear cover from the both end, and as it is 50 by 50, we are deducting 4000 by minus 50 by 50, that is 3900 divided by 150 plus 1, and it is coming number 27. So in F1 foundation, bottom main bar is length is 6.15 and number is 27 number. Now we have to calculate these this bar L portion, that is 350. How? 450 is the total depth of the foundation, and what is the clear cover? 50 in the top and 50 in the bottom. So here it is 450 minus 50 minus 50. It is 350. Okay. So total number of bar is 27. In 6 to 5 direction, it is a straight bar, and this bar in 4000 direction, 150 center. So number of bar is 16, diameter is bar of 16, number of bar is 27. And what is A, B, C, D and lab? Why I'm making this? Because the standard format, and B is the L portion, A is the straight portion. Some bar has the U bar or some C portion like this. So that's why whenever you are making the stair bar bending schedule, there are C or D part also. That's why. But here it is only we need A and B now become 350. Now what will be the number? And now how we will calculate the cutting length? Because from the 12 diameter bar, we have to cut the bar and we have to bend. Now we need to understand what is the cutting length. Cutting length is that we need to provide to the steel fixture or the steel binder. They will cut the bar accordingly, and then they will make bend and they will place in the foundation. Now in this, see, here is a bend, one bend, and there is another bend. There are two bend. And what is the bend the angle? That is a 90-degree bend. Now we need to understand this. If there is a 90-degree bend, there is whenever we are bending, there is a length is increasing. Now we need to deduct this length, otherwise the L portion or the straight portion will be more, it will not fit in the foundation itself. Now how is number of bend here? It is 2, 1, 2. Now we have to calculate the cutting length. See how we calculate G12, that means this one 6150 plus 350, and then C and D and lap is not there, then 2 into bend, 2 number of bend, and 2D is 2 into 16. 16 is the diameter and 2 is the 2D. So whenever is a single bend of 90-degree, 2D will be minuses from the total length, and if there is a 2 bend, that's why 2 into 2D and the 4D will be minus, and this one's this plus this, because it's a 2, this, and then number of bend minus 2 into D, it is coming 6.786. So this 6.86 we need to provide to the steel fixer, so that whenever they will get the 12-meter diameter bar, they will cut 6786, and then we need to tell them that we need 6150, then there will be a bend and there will be bend, and they will make 2 bend, and they will make a U-shaped bar or the L-shaped bar, and these accordingly they will cut the bar or the 27 bar, because we need the 27 bar number of bar in the foundation. Now how will we calculate the total length? Total length will be calculated this into this, so it is coming in the millimeter, it is coming in the meter. 183 into 0.222 is the total length of the bar required for the foundation, but each bar will be 6.786 into 27 numbers. Now how will be the total weight? See, here is a formula you have applied. It's the same way we have to also apply, so that whenever we will making it a 16, it will come into 16. If I place it to make it 12, it will automatically come to the 12 bar. If we place here in the bar diameter 20, it will automatically come to the 20. But in our cases, it is 16. So place is 16. In Excel, you will find out easily this formula. If this formula you should use here itself whenever we are preparing the bar bending schedule. Otherwise, every time we have to make it manually and make it multiply manually, and we will put it in the Excel format. But if we place like this or you use this formula, it will automatically take the required bar length. Now we'll find out the bottom bar is 27 number, 16 dia. Straight portion is 6150, vertical portion is 350, number of bend is 2, cutting length is 6.78, and 183.22 running meter is total required, and total weight of the bar is 289.12. How? This total length into 1.578 of the unit weight of the 16 mm bar. And how it will be calculated? It is easily d square by 162, and you will find out easily what is the unit weight. Now the bottom main bar we have already find out all the details. Now we need to place the bottom distribution bar. What is the bottom distribution bar? Again, it is 16. And how will be number? Here itself in the opposite direction. So in the main bar, it will calculate it in 4 meter like this, but in the distribution it will be in the 6.15 meter. Why 6.15? Our length is 6.25. Again, we need to deduct the clear cover area, because in this clear cover area no bar to be provided. So 6150 again divided by 150 plus 1. So total number of distribution bar is 42. And what will be the length of the straight portion? As it is a 4 meter, so a 4 meter minus 50 minus 50, it will be 3.9 meter is the straight portion. Now again we need to take the vertical portion. Here it becomes 350. Now here it is will not be 350, because first it is 50 50, it will be deducted, then 450 minus 450 minus 50 50, clear cover. Now it is placing above the main reinforcement. That means the main reinforcement dia is 16 mm. That 16 mm dia to be deducted. Again, it will, whenever it will match with the top reinforcement, again it will be catch up with the bottom top distribution, and for that the top main reinforcement bar diameter also will be deducted. So top main also is 16 and bottom main also 16. So here minus 16 minus 16, it is coming 318. Now here it become 350 for the top bottom main, but from the bottom for the bottom distribution it becomes 318. So whenever we are preparing these things, we should need to be taking care whenever we are preparing any bar bending schedules, that bar bend for the distribution, the main diameter of the main bar to be deducted. And same way, number of bend is 2, so it will be deducted, and again it will come 296. In the same way also, top main reinforcement and the bottom top main bar and top distribution bar we are calculating, and here it's still coming for one foundation it is coming 1171. Now if we want to make say suppose 5 number foundation is there. Okay, so this is 1171 kgs for the one foundation, and suppose we have 5 foundation. Here we will make 5 foundation, number of foundation. Here we will make number of 5 foundation. 5, 5, 5. Now see, we are getting 5.855 kgs, 5.855 tons. So one foundation we will put here number of foundation 1, 2, 3, 4, whatever, and as per that we will get the total length or total tonnage of the steel. And if it is only 16, suppose the bottom distribution bar is 12. Now we are placing 12. Again top also 12 again. So it will give dia wise total tonnage of the steel. So we can find out easily what is our requirement is from a BBS. So and from that BBS, we can find out the diameter, spacing, number of bar, shape of the bar, cutting length, total cutting length, and then total quantity of the each diameter bar. And we can then find out total tonnage of the building, or if we find out, if we make all bar bending schedule of foundation. So I make one bar bending schedule for one foundation F1. If you find it is useful, kindly subscribe my channel and hit the bell icon. So whenever I will upload a new video, you will get immediate notification. And other foundation F1, F2, F3, F4, this is your homework. You will do that. And if you find any difficulty, please let me know in the comment section. I will always there to help you. And if you want to know anything about construction procedure, construction material, or any quality control procedure, please let me know. I'll be happy to share with new content, and I'll be happy to help you. And thanks once again for watching me. And I'm waiting for your valuable feedback, so that from your feedback, everybody can be benefited. And thanks again for watching.